So now we've got some vectors in 3 dimensions. Basically, the work is the same in 2 dimensions. We just have an extra number to tag along. So given these points, A, B, and C, that was a dramatic pause, so you have time to write down points A, B, and C. Then the first thing we're going to do, part A, is find the vector from A to B. So that means that you just subtract, start with the B, and then subtract A. So the B minus the A, that would be -4 minus 1, and then 7 minus 2, and then 8 minus 3. And that turns out to be a -5, a +5, and another +5. So that's nice. 5, 5, 5 for everybody. Somebody got a negative. And eventually I want to find the measure of angle A, so I'll also need to go from A to C. So still a part of this one, also find the vector from A to C. So that's going to be the C minus the A. So I need to be able to see it. So C minus A will be 2 minus 1. And next will be 1 minus 2 for the y component. 1 minus 2 is a -1. And then an 8 minus 3. Oh, sorry, I looked at the wrong. No. Sorry, it was covered up. 8 minus 3 is a 5. All right. So we've got our two vectors, AB and AC. And then I just want to visualize real quick. So I'm going to go over to the GeoGebra. And here's the points. A, B, and C. So you can see those. And then if I connect them, we're going to be finding angle A. And if I look at it like this, then to me that looks like it is going to be a little bit less than 90 degrees. Because if the segment from A to C lined up with the z-axis, that would move the A to B down a little bit, but not very much. So I'm thinking maybe around 80 degrees. That's my estimate. And then also when I do that over here on the left, it says the segment from A to B is an 8.66. So when I turn on the A to B, it says that its length is 8.66. And then let's check and see if that's correct. So part B, find the length of the vector from A to B, which is also going to tell us the distance between A and B. So then that's going to be the square root of, and just use the components and square each one. So that's going to be a, oops, not in a highlighter, in a pen. That's going to be a 25 plus another 25 plus another 25. So that's the square root of 75. And the square root of 75 is exactly what the GeoGebra said. It's 8.66. Okay, so this one is done. This is 8.66. All right, the next thing to do is find angle A. So angle A means that you take the AC, I guess I should have started with AB. You start with the AB and then do the dot product with the AC, divide by the length of each one, and then that's what cosine of the angle equals. And I'm just going to use theta for the angle. All right, so for the dot product, what I need is this vector and I need this vector. Okay, so there's my two vectors. I can even line them up like this. So do the dot product. All right, so cosine of theta equals, and then for the dot product, multiply the two x values, which will be -5, multiply the two y values, which will be -5, multiply the two z values, which will be +25. And then for the length of AB, well, that's what we just did. That was the square root of 75. And I'll put the square root of 75 instead of the decimal approximation. And then for the length of the AC, so that's going to be the square root of a 1 squared plus a 1 squared plus a 5 squared. So that's going to be 27. So let's see, on the top, that is going to be 15, and on the bottom, it's the square root, and you could just make one square root and say 75 times 27. And then switch over to the calculator and take cosine inverse. So I would like the answer in degrees. Is it in degrees right now? It happens to be in degrees, that's good. And then take the cosine inverse of a 15 on top divided by a square root of a 75 times a 27. So my estimate was that it was going to be 80 degrees. It's actually 70.529, which is why you always measure twice and cut once in construction. 70.529 degrees. All right, there's the angle between them. Next, find the line that goes through AB. What part is this? Part D already. Part D, find the function f of t that is the line that goes through A and B. So you just have to take the vector AB, which was the -5, 5, 5. And then you also need a point, and it could be either A or B. I'm going to use A. And then just multiply the vector by a t and then add the point. So the function is going to be, take the vector -5, 5, 5 times t, and then add, and then you change the point into a vector, 1, 2, 3. And I would prefer to put this all together because it saves a little bit of time later on. So this first component is going to be -5t plus 1. The middle one, or the y component, is going to be 5t plus 2. And then the z component is going to be 5t plus 3. And then I want to go back to the graphing calculator and check that. So back over to the graphing calculator, and I'm done with this segment. And then right here is where I put the function. So turn that on, and then you could see, yep, that does go through A and B. All right, so that's good news. Whoa, stop spinning. And then for the next part. So if that was part D, this should be part E. So where does that line, f of t, intersect the plane? And let's just go with 2x minus y plus z equals a -2. So if the x, y, and z are just being multiplied by numbers and added and subtracted, then it's a straight flat plane. If you start squaring things, then that causes curvature. If you take sine, then it's going to make it go up and down and up and down. But this is just a flat plane. And that's why just a moment ago I said it's a good idea to put it in this form, because then you could say this is what x equals, this is what y equals, and this is what z equals, and then just plug them in for the x and the y and the z. So the first one would say 2 times x, and then replace the x. Next it's minus y, and then replace the y. And then it's plus the z. And then I just randomly made up the number -2. So I am confident that this is going to have an answer, because the vector for this plane is the vector 2, -1, and 1. You just take the coefficients in front of the x, y, and z, and then that is not parallel to -5, 5, 5. So I know that they're not parallel. If they're not parallel, they have to intersect. And then just do the algebra. So we've got -10t plus 2, -5t minus 2, plus 5t plus 3 equals the -2. And we could do things like cancel, 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 cancel. That worked out pretty nice. Then all I need to do is subtract 3 from both sides. And we're left with -10t on the left and a -5. So once you divide, it looks like t is equal to a half. So after half a second, the line is going to intersect the plane. But the directions said where, not when. So now we just need to take the 1/2 that we just got and plug it in for the x, the y, and the z. So back over here, these purple ones. So substitute 1/2 into each one. So then x is going to equal, so I can just read it from right here. So -5 times a half plus 1. So that is a -2.5 plus 1. So x equals a -1.5. And then this is the y component. So y will equal a 5 times a 1/2 plus a 2. And so that is a 2.5 plus a 2 is 4.5. And then z is equal to, so I need this one's component is 5t plus 3. So 5 times a half plus 3, which is going to be 2.5 plus 3, that is 5.5. And then I should write it as an ordered triplet. So x was a -1.5, y was a 4.5, and z a 5.5. So that is where they intersect. And then of course I want to look at the graph and make sure that that point is correct. So back over to the graph, and I graphed that as point D. And so you could see that point D is on the line. So there's point D. And then graph the plane. So turn that one on. And then you could see that the plane and the line do intersect at point D. So my arithmetic was correct. And we're done.